substitution reactions and examine examples. We will define addition reactions and examine some examples. We will define elimination reactions and examine examples. And lastly, define addition and condensation polymerization. The key concepts covered are the following: substitution reactions, addition, elimination, and polymerization. Firstly, let's look at the reactions of the hydrocarbons. Remember, organic compounds such as hydrocarbons containing carbon and hydrogen atoms mainly undergo the following three types of reactions: substitution reactions, addition reactions, and elimination reactions, which we're going to discuss further in this DVD. Inorganic substances mainly undergo acid-base reactions and redox reactions, but some can undergo the substitution and addition reactions. Firstly, let us examine the substitution reactions, the first type of reaction. Substitution involves replacing an atom or a group of atoms by another atom or group of atoms. So there is a substitution. When you substitute for somebody, you replace that person. So this reaction is substitution in alkanes. We're going to look at where an atom is replaced by another atom. Alkanes are the hydrocarbons that are single bonds, and remember there will be no double or triple bonds. Only a few alkanes are reactive with the halogens. The halogens are the group 7 elements: chlorine, fluorine, bromine, iodine. And the hydrogen atom on the alkane will be substituted by a halogen atom. So a hydrogen atom will be replaced by a halogen atom. An example in this case, we'll look at methane as your alkane, and that's shown by the structural formula below: 1 carbon and 4 hydrogens. Remember, carbon has 4 bonds. And we're going to add the diatomic molecule of chlorine, the halogen chlorine, and it exists as a diatomic molecule, 2 atoms. Diatomic, 2 atoms. So now chlorine as a gas will react with methane as a gas, and we will get a substitution reaction. What happens is the hydrogen on the methane and one of the chlorines of the chlorine gas will be substituted. Have a look what is formed. In this case, chloromethane and hydrochloric acid. This reaction takes place in the presence of sunlight. It requires sunlight for this reaction to occur, and therefore it is called photo, meaning light, and chemical. So a photochemical reaction occurs. Continuing with substitution reactions, we're now going to look at substitution reactions in the alkyl halides. First of all, the alkyl halides react with a strong alkali or water, and the halogen is replaced by a hydroxyl group, the OH group, and will form an alcohol. An example here is the chloromethane, which is an alkyl halide. There's the alkyl group and there's the halide, and reacting it with water, both of these liquids, we find that the chloride, the halogen, here the halogen is replaced by a hydroxyl group, and you can see there methanol is formed and HCl, hydrochloric acid. So an alcohol is formed, in this case methanol. Substitution reactions in inorganic compounds. An example is in a copper 2 chloride solution, an hydrated copper ion can undergo substitution, and we'll see in this case here we have copper with waters of hydration and the sulfur, and that forms a copper sulfide and water. This is a substitution reaction in that the hydrated copper ion undergoes substitution and forms the sulfide. Looking now at the second type of reaction, we have discussed substitution reactions. Now we're going to discuss addition reactions. Addition involves two molecules combining together to form a single new molecule. Addition, adding. This occurs in alkenes and in alkynes. Remember, this is a double bond hydrocarbon and a triple bonded hydrocarbon. The double and triple bonds break easily in a reaction with simple molecules, and therefore you can get addition across the double or triple bond. The hydrogens or the bromines can easily be added into a reaction, and so simple molecules can be added across the bond. Let's look at an example of addition of hydrogen. This is an example of an addition reaction. When we add hydrogen gas to an alkene, remember an alkene is a double bonded hydrocarbon, and we're now going to add hydrogen gas. In the presence of a nickel or platinum catalyst, this is the inorganic chemical added, nickel or platinum, it acts as a catalyst and therefore speeds up the reaction, causes the reaction to occur faster. An alkene is then converted into an alkane, and we can see by the process of adding the hydrogens, the double bond is opened up and the hydrogens are added across the double bond, and we form an alkane, which is a single bond. So this process is called hydrogenation. The double bonds therefore become single bonds, and the product becomes saturated. Now when we say saturated, it will be that there are only single bonds in the product. In other words, it cannot take in any more chemicals. It's saturated. When a sponge is saturated with water, it can't take in any more water. And therefore, with single bonds, the product is saturated. If there are double bonds, it would be termed to be unsaturated, and therefore can have further addition of hydrogen. An example, the addition of hydrogen to ethene, remember this is a double bond ethene, is used to manufacture margarine from vegetable oil. So we are able to add hydrogens onto ethenes. And an example here is shown where the ethene is a double bond and we add the hydrogen and it converts the double bond into a single bond ethane, and this is therefore saturated and this compound is unsaturated. One can see this in the manufacturing of margarine. Here we see the molecular formula written for this compound, C2H6, which is ethane. This is the alkane and this is the alkene. So the addition of hydrogen, the hydrogenation process, has converted the alkene to an alkane. Let us now look at the addition of halogens. This is another type of addition reaction. We looked at the addition of hydrogen. We're now going to look at the addition of the halogens. Here, alkene, it's a double bonded hydrocarbon, is bubbled through a bromine solution at room temperature. Sunlight is not required. Bromine liquid is this color, a brownish color liquid, and the bromine joins the alkene by breaking the double bond, and what occurs is that discoloration the water will no longer be the brown color. And the reason being is that if you look at this equation, we'll see the alkene here with a double bond, and added is the bromine as a liquid. The double bond is opened up and the bromine attaches to the alkene, and what would then occur is that bromine liquid is no longer the brownish color and the color would disappear. And therefore this shows, or could be used as a test for determining whether there is an alkene present. The reaction can be illustrated as follows. Here is ethene with a double bond and bromine solution, which is a dark brown color. Now what would occur is one bromine attacks there, the other there at the double bond, and the double bond opens, and we will get 1,2-dibromethane forming. Okay, this is ethane, and we have 1,2-dibromethane being formed, and the bromine solution, which was a brown color, would discolor as it would lose its brownish color since the bromine is no longer present in solution and it is attached to the ethane. So this could be used as a test to see whether a double bond is present. The next type of addition reaction we're going to look at is the addition of steam. Using a solid catalyst, steam, and a gaseous alkene, they are used to produce an alcohol. And an example of this is in the industrial production of an alcohol using a catalyst of phosphoric acid. An example, ethene plus steam would give us a product of ethanol. Let's have a look at the equation. There's ethene as a gas and water as a gas, steam, and what happens is we produce ethanol, the hydroxyl group added on to one of the carbons and the hydrogen added to the other carbon. So let's have a look in structural formula. There's an ethene molecule and the water molecule as steam, and one can see here the hydrogen is added into that carbon, this double bond opening up, and the hydrogen added in there, and the hydroxyl group going onto that carbon, and we would then get a alcohol formed, and this case ethanol. There's the OH group, which shows us it is an alcohol and therefore ends in -ol, and this is ethanol. The last addition reaction we're going to look at is addition polymerization. Polymerization is also an addition reaction, and identical molecules join together to form long chains, and importantly, one molecule is called a monomer, two a dimer, and many are called a polymer. And if we look at an example which is very common is ethene, and that's the monomer, and when we repeat many ethenes combined together and we form a polymerization reaction, we form polyethylene. Let's have a look at ethene as the monomer, and we combine them under high pressure and heat and a catalyst. The double bonds break and we form longer chains, and these longer chains combine and they form what we call polyethylene, which is a polymer because it consists of many molecules. So from a monomer it forms a polymer, and this is called polyethylene. The next group of reactions we're going to look at are elimination reactions. Elimination involves the removal of a molecule from another larger molecule. An example here is the dehydration of alcohols. Dehydration meaning a water molecule is eliminated or removed. So a water molecule is eliminated and hence it will be called an elimination reaction. An example here is ethanol vapor will be passed over a catalyst, which is hot pumice, and we would get ethene being formed and water. Here you can see the water or the steam is removed from the alcohol, and this then forms a double bond, an alkene. Let's have a look at that in an equation form. Here we have ethanol, the OH group, showing us that it is an alcohol. Meth-eth, it is ethanol. Now this ethanol as a gas or a vapor passed over a catalyst, and what occurs is that water is removed. So the OH is extracted from this carbon and one hydrogen from this carbon, and you can see a double bond is then formed and we have water. So the dehydration of the alcohol, dehydrating the alcohol, is extracting or taking out the water from the alcohol. By taking out the water, one forms the double bond there, and therefore ethene is formed and we have water or steam. So here we can see in this case the alcohol forms an alkene, ethene, and water. Looking at another example of an elimination reaction, we're going to look at the dehydrohalonation of an alkyl halide. Dehydrohalonation. In that case, a water and a halogen are removed. So let's have a look. A hydrogen will be removed and a halogen will be removed from an alkyl halide. The product of this reaction is again an alkene, a double bonded hydrocarbon. And if we look at this example, here we've got an alkyl halide and it's a liquid form, and we place it in alcohol, and what occurs? First of all, one hydrogen is removed from that carbon and the halogen is removed. So a hydrogen and a halogen are removed from this alkyl halide. Now, when the hydrogen and the chlorine are removed, it forms the double bond, and so therefore the product is ethene, or an alkene gas in this case. Now the alcohol that is formed there, KOH, remember we have a hydrogen and the chlorine coming from this, and the potassium would combine with the chlorine forming potassium chloride salt, and the hydrogen would combine with the OH from the alcohol and form H2O, the water. So we get a salt and a water being formed, but remember from the alkyl halide we get an alkene double bond being formed over here. This is called ethene. So from this, ethene is formed, a salt, potassium chloride, and water. The last type of elimination reaction that we're going to look at is cracking. This is a process to produce useful unsaturated hydrocarbons from saturated hydrocarbons. And cracking involves splitting of the large hydrocarbons. So an example of this is when ethane is cracked at a very high temperature, 900 degrees Celsius, to form ethene, and then ethene is then polymerized to form useful plastics. So we actually see ethane in the cracking process is converted into ethene, and hydrogen is released, and if we put it in a structural formula, there's the ethane is then formed to ethene and hydrogens produced, but this ethene is then polymerized to form plastics. We're now going to examine elimination reactions in industry where condensation, polymerization occurs, and this is used in the making of polyester and nylon fabrics. In this case, water molecules are eliminated from reactants and remaining molecules are linked to form long chains. So one can see here's the condensation process where the water molecules are eliminated, and when molecules are linked to form long chains, it is called polymerization. So this reaction would be a condensation polymerization reaction, and water molecules are eliminated. So an example of this is in the plastic and textile production industries. So we have come to the conclusion of this DVD, and it's important to revise all these reactions in the organic chemistry section. And the reactions, remember, are addition, elimination, substitution, and polymerization. Additional challenges that you need to look at are in your study and master book, grade 11, and additional challenges on the organic reactions are activity 14, which is investigating addition and substitution reactions of alkanes and alkenes, page 292 to 293. So remember to practice all these organic chemistry reactions and understand them all. So remember, be cool with chemistry.